Hi, this is GCSE 9 to 1 Crammers. It's never too late to start revising, and this way you can do it anywhere. Test yourself by stopping the video after each question. Have a go at answering it and then play on to check your answer. Run through the questions as many times as you need until the answers pop into your head. Today we're revising topic 4, acids and alkalis, and we'll be covering acids and alkalis, strong acid and weak acids, keywords and facts, and quick tests. Acids and alkalis. Acid is when a substance has a pH of less than 7. Alkali is when a substance has a pH of more than 7. When dissolved in water, an acid will form hydrogen ions, H+ ions. When an alkali is dissolved in water, it will form hydroxide ions, or OH- ions. Strong acids and weak acids. Acids. Strong acids have a pH range between 3 and 1. Strong acids completely ionize in water, releasing more H+ ions, and are more reactive than weak acids, which have a pH range between 4 and 6. Weak acids don't fully ionize in water, only releasing a few H+ ions, and are less reactive. Keywords and facts. Do you need to learn all these for the exam, you may ask? Well, yes, you do. Acid strength tells you what proportion of the acid molecules ionize in water. Strong acids, a lot of acid molecules ionize in water, whereas weak acids, only a few acid molecules ionize in water. Concentration of an acid measures the total number of dissolved acid molecules there are in a certain volume of water. In other words, how watered down the acid is. It is not the number of molecules that are ionized to produce hydrogen ions at any given moment. Dissociation of acid is the separating of acids to release ions in water. Acids are dissociated or ionized in water. In strong acids, nearly all acid molecules dissociate or separate, so they're fully ionized, to release lots of H+ ions, whereas weak acids do not dissociate completely, that is, separate completely, so they're not fully ionized and only release a few H+ ions. What does the pH of an acid measure? The pH is the measure of the concentrations of H+ ions in a solution. Strong acids have a lower pH, around pH 3 down to pH 0, and a higher concentration of H+ ions because they dissociate or ionize more than weak acids, making them more acidic. Weak acids are the opposite and have a higher pH between pH 4 to pH 6 because weak acids have a lower concentration of H+ ions because they don't fully ionize. Effects of acid strength on pH. For every decrease of 1 on the pH scale, the concentration of H+ ions increases by a factor of 10. For example, pH 3 has 10 times higher concentration of H+ ions than an acid with a pH of 4. Give the equation that describes how the concentration of H+ ions changes for a given change in pH. Factor H+ ion concentration changes by 10 to the power of minus x. X stands for the difference in pH. To work out the difference in pH, take the final pH and subtract the starting or original pH of the solution, giving you the difference in pH. For example, if the starting pH is pH 2 and the strong acid solution changes to a pH 5 when an alkali solution is added to it, to find the difference in pH is 5 subtract 2. Do the maths, and the difference in pH equals a positive or +3, which we will substitute with the x in the equation. But it is a negative or -x, so we must deal with this first. In maths, a minus and a minus make a plus, and a plus and a minus make a minus. So +3 and -x will make a -3. Now we substitute the -x in the equation with -3. If the pH of a weak acid fell from 6 to 3, Following the addition of hydrochloric acid in an experiment, how would you calculate the difference in pH? You take the pH figure it has changed to. 3 subtract 6, the pH it started at. Do the maths, and it equals -3. This tells you the concentration of H plus ions changed -3 times. Use this figure in the equation. Factor H plus ion concentration changes by 10 to the power of -x. Substitute the x with your figure, giving you 10 to the power of -3. In maths, you know that a minus plus a minus equals a plus, changing the figure to a positive number, 10 to the power of 3. So the H plus ion concentration equals 10 to the power of 3. Do the maths, calculate 10 to the power of 3, which equals 10 times 10 times 10, which equals 1000. This tells us that pH 3 is 1,000 times higher than pH 6. Following the addition of an alkali to a strong acid solution, the pH of the solution changed from 2 to a 6. Calculate the difference in pH. We put the pH the solution has changed into the sum first. 6 minus 2 equals 4. This tells us the concentration of H plus ions changed 4 times. Using the equation, factor H plus ion concentration changes by 10 to the power of -x. We must work out what -x is. We know the figure 4 will be substituted with the x in the equation, but will it be a negative or positive? In maths we know a plus and a minus makes a minus, so -x will be -4. Next, work out the H plus ion concentration, which equals 10 to the power of -4. The minus means 1 divided by, and the 4 means there are 4 lots of 10s. That is 10 times 10 times 10 times 10. Do the maths, and this gives us 1 divided by 10,000. Do the maths again, and this tells us pH 6 is 0.0001 times lower than pH 2. These may seem to be a bit tricky to start with, but keep going over these examples until you get your head around how to do them. Examples of strong acids: hydrochloric acid, HCl, sulfuric acid, H2SO4, nitric acid, HNO3. They all completely ionize in water. All the acid particles dissociate to release H plus ions. Strong acids can be described as dilute. Explain why. Because there is a small amount of acid per unit volume. Strong acids are described as strong. Explain why. Because they are completely ionized or dissociated in an aqueous solution. Describe weak acids. Weak acids do not fully dissociate or separate in water, or do not fully ionize in water, so they do not release the H plus ions. They only have a few H plus ions. They're less reactive than a strong acid, and lastly, they have a higher pH than a strong acid, between pH 4 and pH 6. Explain the ionization of a weak acid reaction. A weak acid is a reversible reaction which sets up an equilibrium between the undissociated and dissociated acids. Explain what the term equilibrium of weak acids means. Only a few acid particles release H plus ions, and so the equilibrium lies to the left. Explain what it means if the equilibrium is to the left. There are more reactants than products made. Symbol equations can also include state symbols. Next to each substance, they tell you what physical state the reactants and products are in. S tells you the compound is a solid. L tells you the compound is a liquid. G tells you the compound is a gas. And AQ tells you the compound is aqueous. It means it's dissolved in water. These are easy to identify, but it may be a bit trickier to know if something is aqueous. Examples of weak acids and reversible reactions. For the exams you need to learn these two examples and their balanced equations. Ethanoic acid, CH3COOH, AQ, an aqueous solution, produces a reversible reaction of H plus AQ plus CH3COO minus AQ. Carbonic acid H2CO3 AQ produces a reversible reaction of 2H plus AQ plus CO3 2 minus AQ. These weak acids don't fully ionize in water and only release a few H plus ions, creating an equilibrium which lies to the left. Ionization of a weak acid is a reversible reaction. Quick test to see how much you remember. Give the equation for the dissociation of ethanoic acid, CH3COOH. CH3COOH AQ, an aqueous solution, produces a reversible reaction of H plus AQ plus CH3COO minus AQ. Explain why ethanoic acid has a higher pH value than hydrochloric acid of the same concentration. Ethanoic acid does not fully ionize in water, so it is a weaker acid compared to hydrochloric acid. Give the definition of a strong acid. Strong acids fully ionize in water, or you could say strong acids dissociate in an aqueous solution. Name 3 examples of a strong acid: hydrochloric acid or HCl, sulfuric acid or H2SO4, and nitric acid or HNO3. What does the strength of an acid tell you? The strength of the acid tells you about the proportional amount of acid particles that will dissociate or separate to produce H plus ions in solution. Citric acid is a weak acid. Explain what is meant by a weak acid. Weak acids only partially ionize or dissociate in water and only have a few H plus ions. Name 2 examples of a weak acid: ethanoic acid and carbonic acid. Give the equation that describes how the concentration of H plus ions changes for a given change in pH. Factor H plus ion concentration changes by 10 to the power of minus x. Describe the difference between the strength and the concentration of an acid. Acid strength tells you what proportion of acid molecules ionize in water, whereas the concentration measures the total number of dissolved acid molecules in a certain volume of water. Explain why a 1 mol per dm cubed solution of hydrochloric acid will have a lower pH than a 1 mol per dm cubed solution of ethanoic acid. Hydrochloric acid is a strong acid which fully dissociates and will have a higher concentration of H plus ions in the solution, leading to a lower pH from a pH of 3 down to pH of 1 or 0, whereas ethanoic acid is a weak acid and only partially dissociates and will have a lower concentration of H plus ions in the solution. Therefore will have a higher pH from a pH of 4 up to pH 6. Dilute hydrochloric acid is a strong acid. Explain why an acid can be described as both strong and dilute. It is strong because it is completely ionized in an aqueous solution, and dilute because there is only a small amount of acid per unit volume. The key to exam success is learning consolidation and keeping this topic fresh in your mind to nail those questions in the Chemistry GCSE Paper 1 exam. If you go over this enough times, you'll be able to answer any questions on this topic confidently in your exam. This is GCSE 9-1 Crammers, and if you like the content of this video, give us a thumbs up, and if you have a question or need help, give us a comment below. And don't forget, smash that subscribe button if you want more Crammers videos for your exam success. Thanks for watching, and see you again soon.